Hello, in this video we're looking at MEI Further Pure 1, the May 2010 paper question 8, which is on complex numbers. Read through the question first. We're given two complex numbers alpha and beta, and we're asked to find the modulus and argument of both of them. Then we're asked to find alpha beta and beta alpha, giving our answers in this form a plus bj and showing working. And we're then asked to plot 4 points on a single Argand diagram. So for part 1, the modulus and argument of alpha and beta. The modulus of alpha is square root of root 3 squared is 3, 1 squared is 1, so that's root 4, which is 2. To find the argument of alpha, it's always a good idea to draw a little sketch, so that's root 3 plus 1j. So we're looking at this triangle here, and therefore its inverse tan of 1 over root 3, which is pi over 6. For beta, we're just looking at 3j, which has modulus of 3, and it's plotted on the imaginary axis, so its argument is pi over 2. For part 2, first of all we need to find alpha beta. That's root 3 plus j multiplied by 3j. That's 3 root 3j plus 3j squared. J squared is minus 1, so that's minus 3 plus 3 root 3j. For beta over alpha, that's 3j over root 3 plus j. And to find that division, we need to multiply numerator and denominator by the conjugate of the denominator. That gives us 3 root 3j minus 3j squared. And difference of two squares on the bottom, that's 3 minus j squared. So j squared is minus 1, so minus 3j squared is 3. We've got 3 plus 3 root 3j on the top, and 3 plus 1 on the bottom. So that's 3/4 plus 3 root 3 over 4j. Finally, plotting these on an Argand diagram, we'll need to draw a scale in one, labelling this as the real axis, and the vertical axis as the imaginary one. Alpha is root 3 plus j, so root 3 plus j is about there. Beta is 3j, which is there. Alpha beta is minus 3 plus 3 root 3j, which is a little bit under 6. You can check that on your calculator. So that's alpha beta. And then beta alpha is 3/4 plus 3 root 3j over 4, which is just a little bit bigger than 1. So there's beta over alpha. Okay, let's have a look at the mark scheme for this question. For part 1, there's a mark for the modulus of A and another mark for the modulus of B, and you are allowed to give your answer in degrees, and a single mark for the modulus and argument of beta, which is rather easier, and again you're allowed to give your answer in degrees. For part 2, there is a method mark for clear use of the fact that j squared is equal to minus 1, and an accuracy mark for the answer being correct. There is for beta over alpha, there's a method mark for the correct use of the conjugate of the denominator. There's an accuracy mark for getting 4 as the denominator, and an accuracy mark for your final answer. For plotting the points, there's a method mark for a diagram with at least one correct point, and an accuracy mark with follow-through, correct relative positions with appropriate labelling. If you want to find videos of other questions on this unit or on other units, please visit the Further Mathematics Support Programme's website. Goodbye.